This is our third video on composition of functions. In this video, one of our functions is a square root and the other is a rational function, and we just want to compose them in one way, f circle g, and find the equation and the domain. So the equation is going to be when we substitute inside of f the expression g of x. G of x is the square root of 2x plus 5. So that means that in the expression f of x, 7 over x minus 11, in the place of x we will substitute 2x plus 5 minus 11. We are going to leave our expression like that, and that will be our final answer for now. So our final answer will be 7 over the square root of 2x plus 5 minus 11. There are ways to rationalize the denominator if we multiply by the conjugate, but for the purposes of this exercise we are only interested in the domain, so we are going to leave everything the way it is. Now, to calculate the domain, we need to make sure that first the expression we substituted, which was g of x, is defined. G of x was the expression that came into f as a substitution. So first we need to make sure that g is defined, and that means that the expression square root of 2x plus 5 is defined. Square root expressions are real numbers if the radicand 2x plus 5 is greater than or equal to 0. So I have to solve this problem. I'm going to subtract 5 from both sides, 2x greater than or equal to negative 5, and I will divide by 2 x greater than or equal to negative 5 over 2. So that's the first restriction in order for the composite function to be defined. The next restriction is that the actual function is defined, which was f of circle g is defined, and that is a fraction, 7 over the square root of 2x plus 5 minus 11. This has two limitations. One is the square root, but I already checked that. So the fact that the root must be defined has already been checked when I did the inequality. My next step is to make sure that the denominator is non-zero, and that means that the square root of 2x plus 5 minus 11 is not equal to 0. To solve this, I need to solve the equation 2x plus 5 minus 11 equal to 0. So I'm going to solve this problem. Square root of 2x plus 5 minus 11 equal to 0. I'm going to add 11 to both sides. Square root of 2x plus 5 equals to 11. And now I'm going to square both sides, and I will get 2x plus 5 equals 121. I'm going to subtract 5. 2x equals 116, and I will divide by 2, and that will be x equals 58. So this is what makes the denominator 0, which basically means here that x must be not equal to 58. If I wanted to write the domain in interval notation, in set builder's notation, I would have written x is such that x is greater than or equal to negative 5 halves, and x is not equal to 58. If I want to write this in interval notation, I will write closed at negative 5 halves, comma, 58 open, union 58 to infinity. And if I wanted to graph the domain, I would have graphed it as follows. This would be my number line. Negative 5 halves is over here, closed circle, and to the right. When I hit 58, open circle, and then continue graphing to the right.